Hello, everyone. Welcome to the Future Store Meetup. Today we have two amazing presenters for our meetup today. So welcome. But before we start with the presentations, Jim and Davor will present a little bit about the futurestore.org community. And please remember that this recording this meetup is being recorded. So if you want to receive it, sign up to receive the newsletters, which will come up next week. Okay, now I'll pass it on to Jim.
Thanks, Natai. Okay, I'm going to share some screen notes we have here. Presentation. Hope you're all doing well. It's the day before St. Patrick's Day. I'm actually Irish, so I don't know if anybody will be celebrating this year, not properly, but okay, so welcome to this fourth feature store for ML Global Meetup. And this is a place you're all welcome to come. Data scientists, data engineers, ML engineers, you're all very welcome. The organizers of the meetup are myself, Jim Delling, and we have Davor Bonaci, who's on the call here from Kaskada. Davor, do you want to say a few words before we kick off?
No, I just want to welcome everybody. It's a pleasure to be able to host this meetup for the community and for educational purposes and to share knowledge among the community. And, I'm super happy to be able to be part of this one with Jim. So Jim, please take it away.
Yeah, I would just like to add that is a terrible photo of me. I see myself there. That's one of the worst. I'm not that bad in real life. Anyway, well, that's scary. So my teeth are slightly better. But so feature stores for ML. So we have this website, featurestore.org, and it's a community site. Ourselves and Kaskada, so Logical Clocks and Kaskada are the main organizers of this, but everyone else is welcome. We'd like to, that's why the question mark was on the last slide. You're very welcome to join us and help us out. There is also associated with the website a Medium publication where you can write articles, and there's a newsletter that you can subscribe to where you get monthly information about feature stores and machine learning. We have had some past meetups. This is the fourth one. Ourselves and Kaskada talked at the first one. We've also had Uber and Spice Machine talk to the second one, and then Airbnb and Feature Forum at the third meetup. And now we've got today's fourth meetup, which is really exciting. Before we get to the meetup we're starting now, we have agreements with DoorDash and Salesforce to give talks at upcoming meetups in the next month or two. And if you are interested in speaking about feature stores or anything related to feature stores, you can go to this link here, featurestore.org, submit a talk, and submit your proposal for a talk. And we'd love to hear from you. Okay, today we're going to start off with Max Boyd from Kaskada. Max is the lead data scientist at Kaskada. He's a Seattle native, and Kaskada are from Seattle. I think University of Washington is her background. He can probably correct everything I say here. But he's the lead of feature engineering at Kaskada. And they're going to talk about a feature store for scientists, not data science, but scientists. And then Intuit. We're really privileged to have Intuit here as well. We have Simar and Anwar are going to talk about their feature engineering solution. And I know they've been one of the first really big companies to talk about their feature store, which I think they helped develop with AWS, but I don't want to steal the thunder of anybody. And we're going to have some Q&A at the end. There will be Q&A after the talks, and you can go ahead and write in the top. There's a Q&A button at the top of your webinar, the Zoom link, and you can ask questions there. There is a chat function as well, but it's better to use the Q&A if you can when asking your questions. So I'm going to stop sharing at this point. I'm going to hand over and present to Max, who's going to give the first talk for tonight. Thank you.
Thank you, Jim. Excellent. Cool. So yes, everything you said is correct. The only reason though this is feature stores for scientists and not feature stores for data scientists is that data scientists wouldn't fit on the title card. So but yeah, real quick about me. I'm a data scientist and machine learning engineer in the Seattle area. I've worked at a variety of startups, primarily focused on human-in-the-loop production systems, typically building models for both fraud detection, real-time pricing, as well as kind of recommendation systems for kind of employees who were doing kind of matching systems. At Kaskada, kind of my role is to kind of help guide and help kind of inform kind of the feature engineering process and challenges that a data scientist faces while we build out kind of our solution for the feature store space. So I wanted to actually talk about kind of the typical goals of a feature store, because our approach ends up being a little bit differently, and I'll kind of come back to that. So typically what I've seen is that there's the four main goals, right? Are consistency between your kind of training and serving environments, typically your production environment, the ability to calculate historical point in time feature values for training, serving features that scale with low latency, and then the reuse of feature pipelines so that you're not kind of redoing a whole bunch of work. And so, in a lot of ways, I want to talk about kind of really this first one, because that's what's been most painful for me as a data scientist, right? Where I've built things in my training environment, and then when I try and get it into production, it's not consistent. Things break down. My models don't perform well, or it's just it takes 3 months for one or two features to get in there due to backlogs, data engineering challenges, etc. Even if features get in at all. So I think of this as actually similar to the solving the works on my machine problem, right? That software engineers have had, but for machine learning, and it's more of a works on my data store problem. So really, like, we have two different kind of data stores that end up kind of, or two different requirements for our both kind of training and production needs, which end up implying different data stores. Training typically requires kind of offline, it requires historical values and kind of minimal latency, concerns, whereas our production or serving cases typically need to be, online, with real time, with current values and requiring low latency. And so typically what this looks like is that you use an OLAP system, or a data warehouse or data lake for training, and an OLTP or a production database, right? OLAP is built for being efficient queries over large values of past historical data, whereas OLTP is generally built for kind of fast, efficient serving of very simple queries, grabbing recent values. Right. And so, like, really what we end up dealing with is we have a tale of two systems, right? The scientist is inside the data warehouse doing their training, and the engineers in kind of the production database making sure everything's fast for serving. And there's kind of this brick wall kind of between the two, right? Where these two things are separate, and that in order to get things from one to the other, the scientist and the engineer meet at the wall and kind of toss things over back and forth to each other and try and communicate. And this ends up with kind of a ping pong effect, right? Where the data engineer grabs something from the data source and then hands it to the data scientist, who hands it back to the engineer, who goes to a different data source. And this ping pong takes months, right? And typically might look like data scientists saying, "Hey, I need this blue circle." And the engineer is like, "Okay, cool, I've built this blue circle for you." And it's like, "Well, this is the wrong blue. Like, well, can you do like a blue no, not that circle, right? Can you do a blue square?" And the engineer says, "Hey, we don't do squares," right? There was a time when I spent weeks building some very cool like count min sketch features that was like, "Yeah, this is really going to boost performance." And the engineers, I took it to my data engineers, and they're like, "Yeah, we can't do this. We can't do this in production. No way." Right. And so eventually the data scientist says, "Hey, can you do a blue triangle or blue diamond?" And engineer's like, "Yeah, we can do that." But at this point, everybody's upset, right? There's been a ton of back and forth. It's been frustrating, to get this process to work, because kind of we're speaking two different languages, we're working on two different systems, and it's very painful, right? And what's worse is when the model finally does make it to production, it generally will, it can fail to perform as well as it did in training. Uh, Typically because the context or the data inside the data warehouse and the data in the production database like don't match, right? The temporal context of the training database like might have leakage, it might have issues, it might have information available to it that the production database doesn't have, right? And so this is kind of really where that historical point in time feature value calculation becomes really critical. right? And this ends up leading to questions where, as a data scientist myself, I was like, hey, why can't I just run queries on the production database, which has terrified data engineers that I've worked with. And I recognize now that's a terrible idea. But and similarly, data engineers ask, well, like, if I implement this feature, like, how much will it actually improve the model? And as a data scientist, I don't know until I actually have it and try it out. And it leads to accusations of, like, what did you do to the data? I don't trust the data between the data warehouse and the production data database. And it becomes like, human sacrifice, dogs and cats living together, mass hysteria. Bill Murray from Ghostbusters, like, said it best. Right. And really, this is, data scientists and data engineers have kind of these different concerns. Data scientists want flexibility. They're focused on their models. They're trying to do, I need to try 10 different things just to find one that works. Whereas the data engineer doesn't want to build 10 different things if we only really want one in the long run. Like, they want lean, efficient systems that are easy to maintain, that are reliable, because they're the ones getting called at 2 a.m. if something breaks down. Right? Data scientists are deeply concerned about the context that their models are trained in and served in, right? Because that's what actually is the difference between something working or not working, right? And so, the training and production needs differ. Like, this is a challenge. So I want to talk a little bit about how that context matters, right? That context of, things were different between our training database and our production database, really can cause things to suffer, right? And so just to illustrate it, right? The phrase "everything is fine," if someone says it and they're meditating and they're happy, that's great. If they're upset, everything is fine definitely means something different. And if you're a dog sipping coffee in a flaming house, everything is fine takes on an entirely different meaning, right? And similarly, just going directly to data, the simple SQL query, select star from customers, totally depends on what database you're hitting, right? If you send this to your data warehouse, you're going to get very different results than what you get from your production database. Right? The context of your data matters, right? And so this is really kind of coming back to that point of, to get consistency between training and serving, the context needs to kind of remain the same, or you need to be able to manage that, right? But particularly when it comes to historical point in time feature values for training, which I recognize is a mouthful. So as a data scientist, when I'm training my models, I have to use the temporal context from the point in time they would have existed. And when serving models, I have to use the current information. And I want to use the most recent kind of current information. Right. And so this to me is like, okay, well, the data scientist needs this flexibility, this creativity to build things and discover and, like, to manage these contexts and understand stuff. Like, so how do you do that? Right. And so I say, the best way to do it is provide an environment where data scientists have the freedom to explore and try new features, such that every feature that they build is easily, productionizable, or basically build them a data sandbox, a feature engineering sandbox. Right. And so where I've seen this happen in the past with an OLAP and an OLTP system is I've sat down with my data engineer, and we've walked through, what do I get to play with, right? And so they've said, everything that the light touches is yours to play with. Don't go into the shadowy realms. And so in this case, it's everything that is kind of the overlap, everything that exists in the same context between the two systems you can use, which doesn't get all the things that I really want. Like, it's still a minimal set, but I'm safe. Like, I don't have to do the ping pong. I know that anything I build is safe to use, right? And then the data engineer's goal is, how do they make the sandbox bigger? How do they make that overlap as big as possible, right? And that's where I see kind of traditional feature stores kind of coming in. So feature stores typically come in and they wrangle these two data systems to say, how do I make sure that these things are doing the same thing, right? How do I make sure that the values in my data warehouse are also going to be kind of the same values in my production database, right? How do I ensure this? Right. And so their goal is make the overlap bigger. And this is, this is good. Kaskada's going to take a little bit of a different approach. We're still tackling these same goals as the feature store. We're tackling the consistency between training and serving, historical point in time feature values for training, serving features at scale with low latency, and reuse of feature pipelines, but we're approaching it a little bit differently. So we've said that, since neither OLAP nor OLTP really solves the problem, they each solve one half, why not build something that does? Right, so we've built kind of a purple circle that's trying to handle both the OLAP and OLTP system, being able to handle both the training and serving in one environment. So that you can say, hey, I'm going to build my feature. Here's the context in which I want it calculated. Right, so Kaskada powers production and grade feature engineering, right? We're a tool for data scientists to come in and say, here's the feature I want, here's the context I want it calculated in, here's the production context, right? And so instead of doing this kind of ping pong back and forth, right, where it's, hey, here's this data, oh no, this isn't good, and you're throwing things back and forth to each other, the data engineer kind of sets up Kaskada kind of for the data scientist, and then the data scientist, anything that they can build in Kaskada is trivially and easily productionizable and is ready for production right then. Right, and so we're kind of an end-to-end platform where data scientists can connect to data, design and visualize, track and approve, train models, and then use those features in production, and then monitor that data. Right, and so really it's Kaskada's a whole new, it's a data infrastructure solution, not just a feature store, it is actually a feature computation engine, right? And so now I'm going to show off a little bit of what that looks like. So I'm actually now inside Kaskada kind of feature studio. This is a synthetic credit card fraud data set. It's largely built, it's about 600,000 rows of transactional data between customers and merchants on credit cards, and whether or not it's fraudulent or not. So here I'm predicting kind of on the transaction level, I've got 600,000 transactions, and I've created a bunch of features, right? So I've created both kind of lookup features of, which merchant, which customer were involved in the transaction, but I've also calculated kind of Z-score features, right? How does this transaction compare distributionally to that merchant's history? Distributionally, how does this compare to that customer's history, right? And so while I've defined all these features, what I've also done is I've been able to say, here's the context in which I want these features calculated. So at the moment, every one of these features is being calculated for each transaction as of 10 o'clock this morning when the meetup started, right? And this is potentially fine for my production case, right? I want the most current values, and I could rerun it again with the exact values right now. But I can also say, actually, for my training context, I actually just want, the first time when a transaction occurred. And I can actually even say, hey, my model is only supposed to be on transactions less than $100, because that's what I've been asked to do. There's another team working on transactions above $100. They're working on a different problem. I can do that. So I can say, this is my model context. I can rerun these features, and they're now going to be calculated across all of these as 574,000 entities now, right, at each specific point in time when they occurred, right? So I'm going to actually go ahead and run it here and just kind of show off that every single one of these transactions is being calculated at a specifically different point in time for that transaction, when that transaction occurred, and giving different statistics for the related entities of merchant and customer based off of what those merchant customers values were at that point in time, right? So if I sort by prediction time, you can see it's kind of all going through from January through June. But even if I take a look at a specific merchant, you can see that their feature values are being calculated, changing and updating, for every single transaction, right? And that each of these transactions are being scaled and normalized to the exact specifics of that merchant. Right. So that's kind of a little taste of kind of how Kaskada is trying to do things a little bit differently, and empowering data scientists to say, here's the context in which my models exist. And, I can build features and then say, this is the context I want it evaluated in. Right. So we're kind of now want to say, hey, please, you're welcome to try Kaskada. We have a data science edition that is you can sign up for on our website, and we're currently seeking out additional kind of enterprise POCs with dedicated data infrastructure, batch and streaming production APIs, and direct access to product and development teams. We would love to get your feedback and thoughts and anything we can do to help out. And then I'd just like to thank everybody for for your time, and I love talking about data science, data engineering, and machine learning. So I'm available for coffee chats at any point in time. So thank you very much.
Great, thanks, Max. That was really interesting. I have a question. I don't know if I'm going to ask questions. What is the compute engine? Firstly, beautiful UI. It looks amazing. Really nice. So yeah, what's the compute? So when you're dragging the thing and it's recomputing feature values, what's the engine behind that?
Yeah. So the compute engine is a proprietary compute engine that we've built. So I am not personally equipped to exactly speak to it. When I've talked to some of our data, some of our engineers, like, oh, how exactly does this work? They get kind of this far off look. Like it's a little bit of our I think our secret sauce, but it's
okay.
Very sophisticated backend that I am not qualified to speak to at all. I just like playing with the results. Smoke
and mirror. It's abstraction is solving your problem. Great. There was a question. Are you willing to share the slides? Actually.
Oh yes, absolutely.
The video I think will be shared. I think we have agreement from the speakers to share the video, but then there may be an additional request for the slides as well.
Yep, absolutely.
All right.
If I may interject, Jim, on your question, we will be sharing more information in the coming weeks and months about kind of how the specific computation works. And we have kind of plans of sharing all of this in coming meetups. So kind of I'd love to invite everybody who is currently on the meetup to tune in future instances about kind of the how the compute itself works.
And if you're a company who's looking at feature stores and you think that they might want to do a POC on this, what would be like the target kind of, the kind of customer who you think would best make use of it right now? Like so, that you would like to, for your POC?
Typically, when we think about POCs at Kaskada, we like to look the most at building machine learning models in production with event-based data. So, typically our focus target tends to be companies that have multiple data scientists who are trying to push models to production with specifically event-based data, typically transaction stream, typically click stream, typically, logs. So, event-based data that can take advantage of analyzing time and differences in behaviors over time. When there is a significant lift from that is a case where we're probably going to shine.
Okay, great. So I think we're perfect timing, 25 minutes, we said. So I think we'll move on to the second talk of this evening. So it's Intuit, and Intuit, we have Simar and Anwar from Intuit, which are very glad to have you here. They're one of the first companies to really talk about running a feature store in production at scale, and I think they helped build it on AWS, I believe. I think you work tightly with the AWS SageMaker team as well, if I'm correct. Yes. I may be wrong on a lot of this. So Simar is the product manager driving product strategy for feature engineering and storage at Intuit. And then Anwar is the big data group manager at Intuit, who has experience of building big data and machine learning platforms. So we really do get this mix of our data engineers here, and then we had, of course, Max's data scientist perspective on things, and I think it's a great to have that here. So guys, go ahead and share your screen, and I'll leave it over to you. And again, please, people are free to ask questions in the Q&A or the chat. And we have quite a lot of participants here, so.
Okay, cool. Thank you, Jim. So I will start sharing my screen. Can you see it? Okay, yes. Cool. Well, first of all, good morning, afternoon, evening, depending on wherever you're joining us from. And thank you for joining us today. I wanted to thank Jim and Davor also for hosting this meetup and inviting us. So my name is Simarpal. You can just call me Simar. I'm the product manager, as Jim said, at Intuit, looking after the feature management platform. And I'm joined with me with my colleague Anwar here, who is the engineering manager for the platform as well. We will be talking about how at Intuit we are managing the machine learning features for our data science community. Right. So just to kind of kick off, I would like to share the vision of our platform for ML features. So basically, we want to enable users, who are like data scientists, machine learning engineers, data analysts, to easily store, explore, discover, and one of the most important goal, that Max also mentioned in his presentation, which is to reuse features, right? So that users can save time and effort and directly focus on the model training and evaluation aspect, right? So with that, I wanted to quickly flash this diagram from Hidden Technical Dead paper. And I know this community over here, this is not new for them, but I wanted to remind everyone that feature engineering is such a crucial piece of this whole machine learning system that it touches so many aspects. And I wanted to highlight that at Intuit, from feature management standpoint, we are involved in several significant areas that are part of building a successful ML system. For example, whether feature extraction, of course, data verification for the features, process management tools, resource management around feature engineering, especially around monitoring, feature pipelines for operational issues. And we have work planned, in our roadmap, but also around feature quality and drift as well. So with that, I wanted to call out, like, since we have been building this platform, like, what are the benefits of the platform that we provide to our data science community? So to build, any production ready end-to-end feature engineering pipe takes a lot of effort, and majority of the users who are data scientists are not trained to build the production grade pipelines and operate them on scale. And we also believe this is not the best use of their time. And we want them to focus on getting the right transformation logic for features and the right parameters and algorithms for the model. So as a platform, we take care of the plumbing that goes on behind the scene to make these ML systems run more reliably. So just to call out the benefits, first, the processing engines, the infrastructure that is involved in the feature engineering and all those pipelining aspect. On our pay path, we provide highly scalable and cost-effective Kubernetes-based feature processing infrastructure to our users. Secondly, as much as possible, the onboarding of end-to-end feature pipeline is self-served with the necessary monitoring that is needed. The pipeline code is organized in version using GitOps, CI/CD through Jenkins. The platform is well integrated, with other components within the ecosystem, like the data lake, Kafka streams, what we call as event bus, and the data catalog services. And last but not the least, specifically for batch pipelines, we provide ways for people to schedule and orchestrate processing job in sequential or parallel manner. So next, I wanted to share with you like the high level, like 10,000 view of the platform. And of course, my colleague Anwar will go into more specific capability details later in the presentation. But at a very high level, if we talk about at the heart of the platform, we have the feature store. because once the user has written the business logic for feature, the rest is handled by the interfaces around the feature store. Now on the left, if you see, we have like these boxes that I've put is around feature processes. So on our pave path, we have people, provided self-served experience for them to write these feature processors, but they could also, depending on some legacy pipelines they have built or their older implementation, they might have their existing feature processor also. So it doesn't stop them from continuing to have the feature processor, but they can still, use the store to continue to ingest the features into it. So on the left hand side, if you see, we have APIs to register feature. Now this is very important to make sure we capture the metadata for feature, as that facilitate in the feature discovery and reuse. The second set of APIs that you see are around publishing, which basically provides the interface used by the feature processor to send features to the feature store. Now, once the feature is sent, they are stored separately in both the online store, which contains the latest value. And I think Max kind of already took away our thunder, and I don't think it's a new thing, but it's quite a standard mechanism of how we are serving the more real time features, and also serving features in the offline fashion. So you also have the the offline store, which provides feature values for model training and batch inference purposes. And on the right hand side, you can see, we have the serving APIs, which facilitate that serving for training and for inference. And as I said earlier, that once the features are registered, they are discoverable in a metadata registry, which is Intuit's data catalog. And then the user can use tools, such as like Hive on EMR or Athena, to kind of query all these features from there. Next, I wanted to talk about, like, share broadly the categories of the customer problems. That has been the genesis of the platform. Uh, if you talk about the first one is around data availability, especially for the use cases related to fraud. Our users were looking for features based on the most recent events. Now, this is not so much of a problem now, I would say, as we have built robust capabilities to process stream events using any user preferred compute frameworks. But this was like the very first kind of problem that you hear from a data science community, that we want the data to be as fresh as possible so that we can have the latest value, especially around use cases related to fraud. The second set of problems is around data consistency. And I think, this also something Max touched base on. This is where the problem around the training serving skew also exists. But we can call about data consistency problem also from a standpoint around feature quality and whether the data actually is arriving as expected or not. The third set of problems are around data usability, governance, and like provenance. Now, user would like to know where the data came from, right? How was it processed? So they need to have that confidence and an understanding before they use it. Now, we have tried to solve this problem using the metadata registry that I spoke about earlier. And we are continuing to make enhancements around feature discovery, because I think to derive the real value from a feature store, we need to have more reuse of features. Next, the high level view I would share on the pipeline, and then I hand it over to Anwar. So, before my colleague get into the details, just wanted to share with you today at a high level, a typical feature engineering pipeline. So you read the features from different types of sources, depending whether it's a streaming or a batch use case. Then you write it. Then you write your feature transformation logic using the capabilities provided as part of the platform, which then you send it to those generated features through our ingestion mechanism to ensure data consistency in the online and offline store to avoid any training serving skews. Next, I hand it over to Anwar, who will walk through some of these things in more details about the platform. And with that, Anwar, take it over.
Thanks, Simar. Before I start, a lot of overlap. Max covered pretty good context. Thank you for setting up the ground. So, from a core capability standpoint, it is very much aligned. I'm really looking at like a mirror when I see your slide, Max. So we are looking at schema. And the schema plays a very vital role in our platform. And this helps us in a lot of different areas, including data consistency, discoverability, and how do we manage the feature at large scale. And then the sophisticated data serving layer is going to provide a low latency for the real-time use cases as well as for the batch and training. So it has to accommodate all the dimensional problem, and we will see more details when we go to the slide. The last mile transformation is basically for our customers when they need to integrate with third-party data at the time of inference, or they have a logic that needs to be implemented just before the inference happens. And sometimes there is a contextual aggregation needs to be happen before training or inference. So we call it as the last mile transformation, and sometimes it is also called just-in-time featureization. So the last one is the most challenging and sticky problem is a backfill. So as you are a ML practitioner, you always have next to better iteration of featureization or an algorithm that you need to deal with. So as soon as you have the logic change or your data, the source data change, you have to replay the data to make sure that your feature is quality and producing the right results as you expect. So backfill is one of the interesting problem, and we will see more in detail. These are all the key capabilities that we want to highlight, but there are more to it. But we stop here for this context, and we can discuss anything that you're interested in. Next slide. So like I said in the previous slide, schema plays a huge role. The schema is predominantly help us managing the data consistency from source all the way to the model. This plays a very critical role in the data discovery and optimized writing to the feature store, regardless whether it is a streaming or batch. And also the schema allows to collect a lot of metadata that is going to help us managing from a compliance and security aspect of it. From a customer data retrieval standpoint, we have our customized partition where customer can define how their data need to be partitioned both in online and offline store. So the data retrieval is going to be very optimized and tailored for the fast retrieval. The sort key is going to help. You can imagine the sort key as like a group by key, right? You can define, I want to aggregate a certain amount of data based on date or month or quarter, or say for example some categorical value. So you can define that key, and what it does is internally, we will see more of the last mile transformation in the next few slides, but I can give you a context here. So you can do a preliminary level 1 aggregation and leave it to the customer or our stakeholders to define their next level of aggregation. To give you an example, at Intuit there are multiple transactions happen every single day between the customers. So now instead of storing those values at the seconds level or minutes level, so we aggregate them towards hourly and then daily. So the level 0 data is at the seconds level. The level 1 featureization happen at the day level. So now any model developer can look at the data they can roll it up to any timestamp they want. Say for example last 7 days or last 30 days or last 365 days. They can look back any number of days, but the least aggregation happen at the daily level. So it is not compute intensive to scroll all the way down to the seconds level to aggregate on the fly. So this eliminates the cost and the performance improvements across the board. So it helps us doing a last mile transformation in a much more effective way. And also in some cases the features are ephemeral and it doesn't have any meaning after some point of time, so we need to have a feature level TTL. So all this information is captured at the core of schema, and the schema is registered at our metadata registry. So it enables a lot of sharing as well as for discoverability. Next slide. So schema also plays a very critical role in terms of consistency, as I told before, and it helps us validating across the pipeline. So as you see this, and it is a self-explanatory diagram, on the left-hand side you see the sources, and it goes through the feature pipeline, and the feature pipeline is powered by our own processing platforms, both batch as well as a streaming platform we have. And feature management platform is leveraging those capabilities, and we build the feature pipeline on top of that. And as soon as that is done, to have a disintegrated architecture, we have an event stream in between where all the features are getting published. From there, where our writers are going to read from the event stream and write into the stores. But while all this data journey goes through the pipelines, we had to ensure there is no data loss and data consistency, and the lineage is maintained from an end-to-end standpoint. So the data schema plays a huge role, and you can see some examples of how this is structured and stored in the store. Next slide. This is a data service layer, and this plays a very simple but effective role. And what it does is basically maintain a single contract, and that goes all the way from training to inference. So from a ML training or execution standpoint, it is abstract out the feature store. It doesn't have to directly connect to the feature store. The feature store is safe and secure in terms of security and compliance reasons. So the access layer provides with a single contract for both training and inference, also for batch and stream purposes. What it brings additional is the data discovery. So you can cover everything, all the access points with the data serving layer. And it also eliminates the training serving skew, what Max was talking about. So it's all a single repository and served through a single access, and regardless of which mode of operating you have. And this serving layer we built, it has a lot of capabilities, like it can support a polyglot storage. So what it does is basically it can read to many different data stores, not just limited to a specific technology. So it can read from any different storage, and it can do a join and merge on the fly. To give you an example, you can read a certain data set from Cassandra, and another data set from Dynamo, and another data set from SQL. And all of these results that can be joined and merged and given back as a single result set. And this is very powerful, and we want to utilize as abstraction layer to distinguish between feature store and ML execution and training environments. And also it has a pluggable logic where customer can plug in their last mile transformation logic. Whether it could be a simple level 2 aggregation, or customer wants to do, say for example, one hot encoding. So everyone does it differently based on their need. Simar? I think I lost Simar. Give me a second.
He came back. He's back again, so maybe he'll share his deck again.
Sorry about that. My internet connection seems to have dropped. Yes, Anwar, please go ahead.
So the plugin logic allows, I don't know how much you can heard. I believe I was talking about.
We heard everything. Yeah, we heard everything.
Okay, all right. So I don't know if the connection issue on my end or Simar end.
It was
so
mine.
The pluggable logic allows to do the customer last mile transformation, like one hot encoding, or they can do a level 2 aggregation, and that is completely customizable. And we can still measure the performance and end to end. It's all intact as a one black box, but it allows you to extend to certain level. And also it provides access control. This is very critical, we as a financial institute, right? So from various products of Intuit needs different levels of aggregation at different levels of access points. And this serving layer does all that to protect a feature store. Next level. Simmer, next slide. So I gave enough context about the last mile transformation, aka just-in-time featureization. So as I mentioned, the level 1 data is stored at the agreed level of granularity. Right now we agreed on daily level, and the level 2 can be aggregated on the fly. And we don't have to store that information because it is reproducible at any given point of time. So it runs. So level 2 is a compute at running at the serving layer, and level 1 is a stored feature at the store. Next question. Feature backfill. Feature backfill is, as I said, it was a critical capability. So we have both stateless and stateful. Stateless is reasonably easier to do because you can just replay the data and you'll get the features as you need. But stateful, it is going to be a little bit interesting because you need to play through the historical event in a certain order to recreate the aggregation properly at any given point of time. So you can think of a backfill like as a parallel infrastructure and the pipeline to run the backfill while the production pipeline is still serving the customers. So the bottom of the left bottom, you will see the event logs. The event logs is basically the historical data coming from the lake. And the replay topic, there is a replay mechanism that you can define what data source and how long you want to look back, basically the time duration. And based on that, the historical data is going to be replayed through the topic and your backfill pipeline. The backfill pipeline is basically, it could be new logic or it could be the existing logic, but you want to just ensure the data quality. So you can use it for A/B testing as well for the same methodology. So the backfill pipeline will run through the incoming data and goes to the next backfill topic. And that's where it is trying to get into online store and as well as an offline store as a separate table. And once customer is happy with the quality of the data, and they can cut over to the new pipeline, and the older production pipeline can be obsolete, or they can decide how they want to do it. So this is at the very high level, and it is a big topic to discuss. I'll stop here and goes to the next slide, and if there is a question, I'm happy to answer that. And the areas that we are focusing for the future is we definitely want to focus furthermore into our compliance and audit control. I just say compliance and access control, but that more of an audit and traceability of the data flow and movement at every stage and every touch point. So that is going to give us accountability at every state of the organization. So next one is the explainable AI. This is to explain not only from a model aspect, also from a feature. So this is going to increase the explainability at the overall use case level. Also, this is going to promote very deep level of sharing as well as discoverability. The next one, from a feature store standpoint, we are going to focus on NLP and image-based, binary-based features and the deep learning models is what we are going to focus. Also, we would like to leverage the feature store in some areas for our decision engines, if possible. And the next one is, this is the most interesting topic to go to the next level of the maturity is the label and the golden dataset management. This is going to allow us to improve the quality and the state of the ML algorithms overall. And obviously, time series database is going to give us a lot more flexibility in terms of real-time querying and just-in-time aggregation. But we already have a certain functionality up and running, but this is going to give us a more timestamp based or event based aggregation and data execution. Next slide. Right, so question and answer. Simmer and I can take some questions.
Thank you.
I don't know if you've opened the question answer box. Are you able to do that? No.
Yeah, I'll take over. Thank you guys for a great talk. Everybody in the audience, feel free to submit more questions to Q&A, and they can be related to any of the talk or generally about the meetup itself. So I'll start with a few questions here. The first question comes from Zian, who asks, is GraphQL also used for online inference? Was there any perf testing? To compare whether it adds any extra latency compared to something like gRPC?
So let me understand this question. Is GraphQL you also used for online inference? Was there any perf testing to compare whether it adds? It is. So let me step back and answer this question, right? So we use the data serving layer for almost like a year and a half now, and that's predominantly on GraphQL. It is battle tested, so I cannot disclose the numbers, but it definitely competing with the gRPC. So it's a very, very low latency. We are talking about low 2-digit milliseconds at TP90.
All right, that's pretty precise. Thank you. And so next question is also for you, Anwar. Can you explain more how live feature calculation is handled from same person?
So this is a stream processing, right? So if you think of it like you have incoming events, and you can do it a few different ways. You can use Kafka, or you can use one of the streaming engine to process. And if you go a little bit in there, and everyone can write a set of steps to generate the features. But what we have done is we created a streaming platform where pretty much all the code, all the pipeline code is templatized. So the customer can just come in and put their logic in their transform part of the module, and everything else has been taken care. So it's a long process, but I try to explain it at the very high level. So you have an event bus. Simar, if you can go back to the slide if possible.
Mm-hmm. Yeah, give me a second.
Take your time.
Yeah,
you can stop here. That's okay. So from our incoming event stream, it goes into our pipeline where customer need to just plug in their logic, featureization logic into the transform module, and everything else is pretty much pre-wired, and that's run in Flink, and it produces the feature row structured data into event stream, and then you have the stream writers right into our online store. So you may think why this is like why you cannot write from a pipeline to all the way to the writer. You can still do that, but we have a reasons to build in such a way. And if you notice that there is a stream writers, and that is a multiple writers, so you can configure and you can do for parallelism. You can do it for, there are multiple knobs to control cost, speed, and scalability.
All right, I think that covers it pretty well. The next question comes from an anonymous attendee who asks, from what interface do users register features? Is it like an API, CLI, website, notebook? What's the interface? How the users interact with the feature store?
Yeah, maybe I can answer to that.
Go ahead.
So yeah, so the way we have built, as I walked you through some of the benefits when I was calling out, a lot of the onboarding is self-served, and we have a developer portal where people can onboard to most of these like pipelines. Like for example, even this pipeline that you're seeing right now, there is actually a developer portal experience which is all self-served. So within that, there is an part called feature set onboarding, and this, so the user can go through actually a UI, few workflows where they can provide that information around the schema. And we also have behind the scene APIs. So currently we haven't exposed APIs yet because I think what we wanted to do was capture certain lineage part. Because if we give people sometime like access to a lot of APIs, people doesn't necessarily follow certain paved path. So, but there are APIs behind the scene, but there is a UI interface currently.
Okay. Perfect. Another person asks, do you have a feature to handle experimental features, right? Like, do you have a way of ensuring tests or test features or experimental features be computed without impacting production features?
Yeah.
We do have different environments to play with, and it is an interesting problem to solve. In the lower environment, we cannot have a certain type of data due to security reasons, right? So it's always an interesting point. This is something that we are interested to invest further more time and effort on it.
Can I follow up on that, Anwar? Jim here.
Yeah.
Just schema evolution, is that a requirement for you to do something like this? To be able to support experimentation, that if you versioned your schemas, you say schemas are very important. How important is versioning them, and do schemas capture everything? That's the other question.
So it's a multiple question, Jim. We support a schema version, obviously. So that's how you can manage backfill, and you can do A/B testing and a whole lot of things. Schema evolution is permitted, but however, we are not having any schema inference on the fly. That's a conscious decision.
And if you do evolution, do versioning as well?
Yes, versioning is allowed. Yes.
Yeah, sure.
Right.
And that's the key for A/B testing and backfill. So if you want to do a parallel run, and I didn't call it explicitly because I was watching time, but yes, it is allowed.
I mean, we can open up to Kaskada as well. I mean, Max, what do you think about schema? Or do you have an opinion on how important schema is? Because Intuit, we're pushing it quite a lot.
Yeah, so I have never met a data schema that has remained unchanged for any particular period of time. So yeah, I know there's kind of a movement with kind of a event-based data and event-based like data stores where you store the raw data and then you enable the schema to change and to basically reinterpret that data, which is particularly good for the machine learning space. But yeah, I'm not. I think that's kind of, I guess, the extent of kind of my opinions that the ability to change and update schema as your understanding of the data source and your business needs change is critical.
Yeah, Jim, I would just add that yes, we support, as you said, evolution of schema, depending on how the changes are made, like are they backward compatible or not. So if there is a backward compatible change, then you do not necessarily have to update the version, right? But if the changes are going to break any existing pipelines, then you have to update the version.
Yep, 100%.
So I also share an opinion here, like this also kind of goes back to Google days and how Beam was built and how we advised people to version things. And a typical advice was for people: always store the original data in a data warehouse, always append it as it is, but try to maintain a pristine version of your data as another copy, as a real data on which you operate. And so when you change schema from today, from what was a year ago, run one-time pipeline, have data engineers and have your team run one-time pipeline that converts all data from this unchanged store to the most recent schema, and have everything else inside your company always operate on one canonical schema that processes all the data. If you don't do that, if you don't do that, you tend to pay the cost every single time on every single pipeline, on every single use case. And so just kind of, that was the general advice we were been giving for years to kind of Beam users. And I've been kind of using that, in the years since, it has worked well for people in general.
+1 on everything you said. So there should be a single point of truth where you can reproduce, retrain, recalculate everything as you need. Nothing set in stone.
There's one question for you, Kaskada, so Davor or Max. On what cloud is Kaskada available, and how is it different from other products like Feast, Tecton, and Hopsworks?
So I'll take this question, and then Max, please add if you have kind of more to add. So Kaskada is available on any cloud. Things are built on Kubernetes and can be deployed anywhere. And for kind of in enterprise POCs, we run on any cloud as needed. We also are operating a generally available product that runs on AWS that you can sign up right now. If you just go through the sign up flow, you can sign up, go through onboarding, and you can get access. And that product is running on AWS. But in enterprise situations, we will do things depending on the customer's needs and requirements and security protocols and so on. In terms of differences with other systems, I tend to kind of avoid the question, particularly because many of these products are nascent, as Kaskada is as well, and things change over time. And so when things get quoted that are a little bit old, I try not to kind of answer too directly. But on a very high level, the primary difference, how we are positioning Kaskada, is a feature engineering platform that targets first and foremost the interface that Max showed, data scientists, and building the bridge from that studio, from the data science experience to production, avoiding things like rewriting pipelines, having different definitions from what data scientists do and what data engineers do. And we are not a feature store in a sense that you store feature values. We are a feature engine that computes features when you need them at any point in time. It is not a cache of every hour features or everyday features, things like that. We answer questions about feature values at arbitrary points in time. And those are kind of technologically maybe the biggest difference in kind of how we like to think about it. But again, I would not like to, go deeper into the analysis because kind of the space is nascent. People are doing amazing work, and we all kind of benefit if everybody does a good job. And we obviously compete, but we also collaborate, and we are really kind of, I think, all focused on helping people achieve success with machine learning in production. And at least I am super excited to see what people will build on top of all of these platforms and make kind of the next generation of products. And that's kind of what's super exciting to me. And specifically in this community, we try to enable kind of vendor agnostic sharing of information, collaboration, innovation, so that we as an industry are successful and that we help people beyond big tech that tends to get most of value from machine learning actually be successful. And I think we all share that goal, and we all are doing our best to enable that.
Great. Let's avoid the second AI winter, or third AI winter. It's on our shoulders. I guess that's it. Thanks for brilliant talks, great discussion, questions, inspiring stuff. And it's great to see, the Kaskada platform. Really excited to see some of the details and that you're gone live. And Intuit, I've looked at some of your talks, and this was way better. We way more detail in today, and it was really good. And I'd love to dig into the Flink stuff. We have a history in Flink and using Groovy and SQL and stuff like that. So maybe some other time we'll get into the details of that.
And maybe for Intuit guys, I have a question for you. Do you have any, call to action? Are you hiring for your team? People that are interested to learn more, can they learn more somehow? Kind of any call to action?
I didn't get your last part, Davor.
Are you guys hiring? Do you have kind of call to action, things like that for the audience? Can the audience do anything for you?
Yes. So we always hire. So
yeah, I mean, I keep telling Anwar, man, we need more people. We need to build so many things.
Besides my team, like there is always opening for the right talent and the right candidate. So please look at our career website, and feel free to reach out to me or Simar. We happy to channel to the right hiring manager or give you the right point of contact to get you there. I can tell you it's a good company to work for. So with the right mindset at every level, it's one of the great company to work for.
So Natalia just said to remind everyone, if you want access to the video, early access, sign up for the newsletter at featurestore.org.
Yeah. And if anyone interested to have a like-minded conversation, please feel free to reach out to Simar and I.
Especially around the areas that Anwar called out, like the area of active development. We would love to kind of, share thoughts and, what's your opinion? Because I think this is such a fast evolving area. Everybody is in different path and journey. So it will be good to kind of share thoughts around it.
Yeah. And they were rightfully called out. Yes, there is a bit of a competition, but there is always a big room for collaboration. So we share notes and learn, because sometimes at surface it may look like a same problem, but we are dealing altogether different problem. But we can learn from each other. We can support each other. Jim, Natalia, thank you for bringing us up here. I appreciate it.
Thank you all. Thank you all for attending this time. We will be back soon. We promise talks from more interesting companies, also from people that have spoken in the past as well. And please engage with us. Please reach out to me, to Jim, submit a talk, sign up for the newsletter. Thank you all, and see you all soon.
Thank you.
Bye, everyone.